review lesson 35 and introduce lesson 36, but what we're really going to do is talk about the unit circle again and answer some of the first questions on both of those. We're not really going to deal with amplitude and K and C and phase shift and vertical shift. We're going to get the basics down because that's where our problems seem to be when you took that test. You didn't really have your unit circle stuff down. So this memory work has to be done. Now, remember, we begin on a circle with 0, and then all the way over here to 90 is pi over 2, and then all the way over here to 180 is pi, and then down here to 270 is 3 pi over 2, and then we get back to 2 pi. Now, we call those quadrantal angles. We're using quadrantal angle values to graph sine and cosine so that we don't have to deal with things like square root 3 over 2 and square root 2 over 2. We still need to know those values from our unit circle memory. We just didn't use them in graphing because they're not very easy to graph. We could have chosen those. We just didn't see the need to be mean to ourselves that way. Anyway, the first thing we got to do is our memory work. If we don't have our memory work, we're just kind of lost, especially if I don't let you use a calculator on the test. So let's go through sine. What is sine of 0? 0. Now that's just memory work. Now, what about pi over 6 in degrees? Pi over 6. How do we figure out what degrees pi over 6 is? Divide 180 by it, right? 180 divided by 6 is 30. So we know that pi over 6 relates to 30 degrees. And we got to be able to do that. You may have memorized sine 30 instead of sine pi over 6, but you have to be able to figure out that pi over 6 is 30. So you can connect it back to your memory work. How do we figure out what pi over 4 is? 180 divide 4. 180 divide 4 is 45. And so we know that a denominator of 4 represents 45. And then we take 180 divided by 3 and we get 60, so we know that pi over 3 has a reference of 60. It's the same thing as 60. Pi over 2, 180 divided by 2 is 90, so that's 90. Pi is 180. 3 pi over 2 is 270, and 2 pi is 360. We made it all the way around. So you really need to memorize, if the denominator is 6, what's the reference? 30. If the denominator is 4, what's the reference? 45. If the denominator is 3, what's the reference? 60. If the denominator is 2, what's the reference? 90. That's just flat memory work. And you know all these fractions pop up all the time, so you just need to know them. Okay, so then from memory in the unit circle, has everybody got those numbers in there? From memory in the unit circle, then what's the sine of pi over 6, or what's the sine of 30? 1/2. Now, some of us didn't remember those when we took that test, so you just kind of missed a lot of stuff. What is the sine of pi over 4, or 45? Square root 2 over 2. What is the sine of pi over 3, or 60 degrees? Square root 3 over 2. What is the sine of 90, or pi over 2? 1. What is the sine of pi or 180? 0. What is the sine of 3 pi over 2? Kind of notice here, it's like going from here to here. It was 1 up there, so it's -1 down there, right? Quadrantal angles change its signs when you go 180 degrees. So that's a -1. We noticed that connection. And then 2 pi is all the way back around to where 0 was, so we're back to 0 again. Now, when we went to graphing things, we decided not to use these little square root 2 over 2s and square root 3 over 2s, so we said if we just want real pretty little numbers, because we're just trying to figure the ups and downs of the curves, then we could just use our quadrantal angles and use those to graph our sine and cosine and tangent waves. Right? and avoid those fractions and radicals. And so what we did is we chose 5 numbers which created 4 gaps. And the numbers we memorized or used were those quadrantal angles. So to be able to graph those functions, we needed to really know that. Now, let's go to cosine. We'll do it in blue so they'll kind of be different. Cosine of 0 is 1. Now we're starting at 1 instead of 0. So that tells you when you first look at a graph, whether it's sine or cosine, did it start at 1 or did it start at 0? Okay? And then cosine of pi over 6 or 30 degrees is square root 3 over 2. The cosine of 45 is square root 2 over 2. The cosine of 60 or pi over 3 is 1/2. The cosine of pi over 2 is 0. The cosine of pi is -1. Do you notice that when we went from 0, we went 180 degrees? In other words, cosine of 0 is 1, but when we go to pi, we get to -1. It changed signs when we went from 0 to pi. So we're seeing that in that. Excuse me. The cosine of 270, 0. Cosine of 360, we're back to 1. And you can see highlighted in yellow, that's the numbers we kept using when we were graphing cosine waves. 1, 0, -1, 0, 1. Okay? It all has to do with our unit circle. Now, that's lesson 35 review. Before we go any further, let's look at some of the questions on the test, or just the review. If we look at the review on page 30, I'm just going to make some stuff up. But we had the question, cosine 8 pi. Well, how are we going to figure out cosine 8 pi? Well, here's what you're really going to think. If I take out an all the way around, what did I take out? I took out 2 pi. Think about taking 2 pi's out of that. How many times could I take 2 pi out of 8 pi? I could take out 4 sets of 2 pi. Now, if I take out 4 sets of 2 pi, what's left? 0. Now, think about writing it like this. That's just symbolic of what's going on. If I take out 4 sets of 2 pi, then what I did is I said, okay, I went around once, twice, 3 times, 4 times. Where am I at? 0. If I go around 4 times, I'm at 8 pi. There's nothing left. And so what I really want to know is what's the cosine of 0? And the cosine of 0 is 1. So the answer is 1. That was the first one on your homework sheet. What was the first one on your test? Sine of what? Sine of pi. Well, that's just memory work there. We didn't even have to go around and around. The sine of pi is 0. That's just memory work. That was like 3 times 4 is 12. I mean, that's just, what I did is I made that test where it was supposed to be just pretty, boom, there it is. Okay, what was number 2 on the test? Cosine 3 pi over 2. Well, that wasn't even a going around and around and around either. Cosine of 3 pi over 2, that's another memory work problem. Those two were just, okay, you either memorized it or you didn't. Okay, but let's make up a harder one. Let's say that we had cosine of 17 pi over 2. Can we handle one like that? Well, let's think about how to handle that. If the denominator's 2, how much does it take to go all the way around? Well, it takes 2 pi, but 2 pi is what over 2? 4 pi over 2. So if I have a denominator of 2, and I'm trying to think, I want to take out all the going all the way arounds, then a going all the way around in terms of a denominator of 2 is 4 pi over 2. So how many 4s can you take out of 17? You can take out 4 sets of 4 pi over 2, and then what's going to be left? A pi over 2. So it's like I took out going around 4 times. So I went around 1 time, 2 times, 3 times, 4 times, and after I got back around that 4th time, I needed to go pi over 2 more, which lands me at pi over 2. So I really don't care about that big old 17 pi over 2. I just want to know what's the cosine of pi over 2. And the cosine of pi over 2 is 0. Y'all see how we're supposed to be answering the questions there on that on the test, the first part, okay? All right. Now, the second thing on the test, any other questions? I can make up some more if I need to. I just want to make sure everybody's got it. Okay. Let me do one more just so I can say I did. Let's take a 4, 5. Let's take an 11. Cosine 11 pi over 2. Okay, let's just do that. That means we could take out some 4 pi over 2's, right? So how many 4 pi over 2's? So how many 4 pi over 2's could you take out? You could take out 2 4 pi over 2's. That would be 8 pi over 2's, and that would leave you with 3 pi over 2's, right? But a 2 pi over 2 is actually a semicircle. See, we're trying to bounce from quadrantal angle to quadrantal angle. We're going to take out all the way arounds, and then we're going to take any halfway arounds out we can take. So I'm going to take out 2 sets of 4 pi over 2's, which is 2 all the way arounds. But then I've got enough to take out a halfway around, 2 pi over 2. That puts me at 10 pi over 2's, right? So now what I did, I took out that, and now I took out a half a circle. Maybe I should start over drawing. Let me draw over. It's getting kind of ugly. Kind of nice that stayed put. Okay, we took out 2 all the way arounds. So we took out 1 all the way around, 2 all the way around. So now we're right to there. We've gone around twice. And we still got 3 pi over 2, and 2 pi over 2 is halfway around. So now we took out a halfway around. Now we're sitting over there at 180. And then we got 1 more of those pi over 2's. So we want to go pi over 2 more, which puts me right here, which is the reference of 3 pi over 2 for cosine. And so we go cosine 3 pi over 2 is 0. Or we could have just said cosine is pi over 2 is 0, either one, if we took out that half a circle too, okay? Because really when we got down to it, our reference is pi over 2, okay? You really got to figure out where you're at, though, because you got to think about the quadrant. So we go back and say, and that's important to think, what if we use the pi over 2? Well, we can do that. The cosine of pi over 2 is 0, but we got to think about what quadrant. Just know if it's positive or negative, because if we had something like a 1, and we were off in the middle, not on a quadrantal angle. If we was out in the middle somewhere, we'd need to know. When we run around and around and around, did we end up here or here or here or here? And then we have to say, is cosine positive in that place? I'm going to be looking at the reference angle to get my number, but I've got to think about what quadrant it ended up after all those all the way arounds and halfway arounds to figure out what the sign of it is. Yeah, everybody understand that? Okay? Okay. Now, let's look at this question. This says, where all is the cosine of theta equal to -1? It wants every single place that's true. So we got to look up here and say, well, I need cosine with an answer of -1. Where was cosine -1? At pi. Is there any other place that cosine is -1? No. So cosine of negative 1, the cosine of what angle is negative 1 pi, but also every time you go back around and get to pi again. Now every time you go around, that's a whole circle, and you can do that over and over and over again. And so we say the set of all times that cosine is negative 1 is at pi plus 2 pi n. The first time it happens, and then every time you go around again and around again and around again and around again. Okay? Now if it's a quadrantal angle, that's what you got. It gets harder if I don't give you a 1, negative 1. So let's throw one of those in there. Let's say that I said, where is sine? I want the set of all places that sine theta is a half. This one's harder. Now, first of all, we got to think, sine of what's a half? Sine of what is a half? Pi over 6. But I got to think about the sign. This is positive. Where is sine positive? In quadrant 1 and 2. Now, I can be pi over 6 right here, but I could also be pi over 6 less than pi, right? Because I can be in quadrant 2. What's pi over 6 less than pi? Well, pi is 6 pi over 6, right? 6 pi over 6 is a whole pi. You take 1 pi out of 6 pi's, you get 5 of them, right? Take 1 pi over 6 out of 6 pi's over 6, and you get 5 pi's over 6. That means we got to write this thing twice. We can start at pi over 6 and go around and around and around and around and around. And we could start at 5 pi over 6 and go around and around and around and around. The answer is this and that. The answer is both of those, if you want the set of all of them, you see. So if I don't give you a quadrantal angle, it's a little more challenging to find the set of alls. Some of you found half of them if you look at your test. You might have got half of them if I didn't give you a quadrantal angle. So give me a test question, and let's talk about that with a test question. What's one somebody missed on a test that asked you to find the set of alls? Square root 2 over 2. There we go. Square root 2 over 2. Okay, so our first thought is the cosine of what is square root 2 over 2? Pi over 4. So that's memory work. If you don't know your unit circle, you're just done. You can't even start, right? So the first thing we're going to say is, well, it's going to be pi over 4. But then we got to think, well, this is a positive cosine. Where's cosine positive? 1 and 4. A smart trig class. 1 and 4. Now, that means we can have pi over 4 in quadrant 1. Or we can have pi over 4 in quadrant 4. Now, in terms of force, all the way around is 2 pi, which is 8 pi over 4, right? So 360 or 2 pi is 8 pi over 4. We want to be a fourth less than that. That means we're at 7 pi over 4. So there's two places that we're going to get cosine theta is a positive. That's in quadrants 1 and 4. Square root 2 over 2 is associated with pi over 4. So we're pi over 4 or pi over 4 less than 2 pi. And so the set of alls would be this plus all the way around over and over and over and over again. And this plus all the way around over and over and over and over and over again. Okay? That makes sense? I know this is hard. This is a lot of stuff that's supposed to be in your brain. It's supposed to all just jump out of your head like it's been there forever. So I realize that that's not easy. I mean, I didn't learn all this the first time I looked at it. I mean, I've been teaching pre-cal 3 or 4 years. I'm just now getting to where I can just pop all this stuff off without looking. And you're supposed to have done it in 2 months. I've been working on it 3 years, so I understand why you're struggling a bit. But we can still get it done. You still need to be able to do this. So we still need to memorize that unit circle. When you really look at it, what's on the board right now is 24 things to memorize up there right now, right? And that's not a huge amount of data. If you really get down to it, that's not a tremendous amount of data. All right. Any questions on that? That's pretty well what we had trouble with on the test. Let's go on and move on to the next thing then. Well, no, let's just graph. Let's graph something. Let's just graph one just so we can say we did, because we may need that. Okay, let's say that we were going to graph cosine theta. Well, we have, look in the yellow by cosine. Do you see we have a table? I mean, we've got a table, and the yellow stuff, 1, 0, negative 1, 0, 1. If we were going to graph cosine theta, we know that we're going to go from 1 to negative 1. And we're going to go from 0 to 2 pi. And our gaps are going to be, see the quadrantal angles, the yellow stuff, pi over 2, pi, 3 pi over 2, 2 pi. And then cosine theta, cosine of 0 is 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 2. All we're doing is going bing, 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 bing. Okay? And all that's in your head. It didn't bing out that fast probably, but that's what's supposed to happen. Okay? Any questions on that? If I put a 2 right here, what's that going to do? Change that to a 2 and a negative 2, because that's your amplitude. That's all it did. What if I put a 2 right there? Then your period is 2 pi over k, so it's going to cut your period in half. So that whole thing's going to happen by the time you get to here. So we're going to cut those in half, right? So now instead of taking all that much time to get it done, it happens in that. So we're going to go bing, 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 bing. I think I messed up. Boom. 1, 0. Negative 1, 0. Positive 1. 1, 0. Negative 1, 0. Positive 1. 1, 0. Negative 1, 0. Positive 1. The whole thing happened in pi instead of 2 pi. We're still using the 1, 0, negative 1, 0, 1. We're still making 4 marks. Bing, 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 bing. Okay? You understand that? All right. Okay, so that's that. Hopefully this is helping you understand. We'll do a retest sometime and you'll do better. Okay, any questions there? So if we do tangent, it's not any different. We're just going to build a table of values, right? Okay. So let's talk about tangent. What is, do we remember that? What is tangent of 0? We're a little rustier on that one, 0. The tangent of 30, square root 3. The tangent of 45, 1. Wow. Yeah, we need to study that one. Yes, thank you. Wow, we need to study. See, we includes me. Let me show you something too, because the tangent of 60 is square root 3, and square root 3 is bigger than square root 3 over 3. The bigger one of those goes with the bigger angle. So if you can't remember which one's which, the square root 3 divided by 3 goes with the smaller 30. The square root 3 without the divide is bigger. It goes with the 60. Okay, so that would all make sense, obviously. Okay, I just wasn't thinking there. Okay, the tangent of 90 0. We knew that. Tangent 90 is undefined. The tangent of 180, back to 0. Now, this is opposite signs here, but the opposite sign is 0, 0. The tangent of 270, negative undefined, still undefined. And the tangent of 360, well, that's back to 0, so it's 0, okay? Wow. So let's do this. Let's try to graph this tangent thing. Tangent 30, theta. That's tangent theta. How high does it go? Somewhere it's going to go to 1, but that's not our quadrants and angles are. Let's just look at that. Let's put our stuff. We've got 2 pi. Let's just put our 2 pi, and then we're going to put our pi. Let me maybe not. Maybe we'll regrid that. So we're going to have 2 pi, and then we'll cut that in half and put a pi, and then we'll cut that in half and put a pi over 2, and then we'll cut that in half and put a 3 pi over 2. At 0, tangent 0. So there's a point right here. At pi over 2, it is undefined. Now what that means is there's a vertical asymptote. There's not an answer there. There's not an answer there. So we draw a vertical asymptote. That means it's going to approach that and never hit it. At pi, we're back to 0. At 3 pi over 2, we're at undefined again. And at 2 pi, we're back to 0 again. Now, can we kind of figure out what's happening in the middle a little bit? Let's kind of think about, between 0 and pi over 2, we have a pi over 6, which is square root 3 over 3. Can somebody throw that in the calculator and see about what that is, square root 3 over 3? We're going to graph that point right there, square root 3 over 3. .57. So when theta is pi over 6, it's 0.5 something. So if we thought about a 1/6 of pi, that would be like dividing this into 3 pieces, right? And that into 3 pieces, so there would be 6. If we think about pi over 6, and this is a 1, then it actually went up 0.5. And so it'd be somewhere about right in here. Seeing that? And what if we took the 1, so at pi over 4, this is a half, so somewhere a fourth would be about half of a half. And so that would be at 1, so that's going to put us right here. You see what's going on? Now, I'm not going to end up drawing this pretty, but if we were to graph that, it would do that. And then if we were to graph, it would do that. And if we were to graph, it would do that. And so what we do is get these little curves that keep repeating themselves, but they keep approaching these asymptotes because it becomes undefined. It goes away, and then it comes back, and then it goes away, and then it comes back, and then it goes away, and then it comes back. Okay? And so what we end up doing to graph a tangent is we really think about where are our asymptotes and where are our intercepts. And then we're not really going to try to get all those other points. We're just going to say it's going to hug up against this asymptote, curve over and grab the 0, and hug up against the other asymptote. Okay? There would be an asymptote here. It's going to hug up against the asymptote, curve over and go through 0, and then hug up against the other asymptote. There would be another asymptote here, hug the asymptote, go over and grab the 0, and come down and hug the asymptote. And so we get a series of those. Do what? So there's not any beautiful numbers. So what we usually do on graphing that is we just figure out where our zeros are. We say, well, there's an asymptote, and there's a 0. That's all I need. I'm just going to go hug it, run through the 0, hug it. I missed my 0. That's all you're going to do. We're not going to try to come up with those crazy other points. Okay? Hug the asymptote, run through the 0, hug the other asymptote. All right, I think I may, let me pause this thing just a second, and then I'll, okay? And then I